Lesson 2.2 and 2.3 are just about solving inequalities. And again, it's all of the same algebra steps that we're used to using. The only difference is going to come when we do multiplication and division. So the addition and subtraction properties of equality are exactly the same. So we can add and subtract just like normal, absolutely no change in rules. So let's write out a couple of examples. First one is x minus 6 greater than or equal to negative 10. And just like in a regular old problem, I'd add 6 to each side. Those 6's would cancel out, and I'd be left with x greater than or equal to negative 4. Most of this lesson is going to ask us to graph our solutions. So simple number line again, negative 4, and then we choose a number bigger. I usually just go by 1 and a number smaller. So we're comparing to negative 4. We decide open or closed circle. The or equal to sign is what tells us closed. And then we decide which way to shade. The alligator's eating the x, so the x is bigger. I want the bigger stuff. Remember, our graph represents x. So if x is bigger, we want to shade the bigger numbers. So that's all it really is right there. A couple more examples. We'll get to the multiplication and division really quick because this should just be review and nothing else. So y plus 8 is less than or equal to 5. I'm going to subtract 8 on each side. The 8's cancel. I'm left with y is less than or equal to negative 3. And we're going to graph that. I really don't think I have to talk through too much here with you guys, so I'm just getting a couple of problems written out so you got something for your notes. So I'm comparing y to negative 3. Choose a number bigger and a number smaller. Again, I'm just going to go by ones. I got my or equal to line again, so this is another closed circle. But now the alligator is eating the number, not my variable. That means my variable is the smaller thing. So I'm going to shade down to represent my smaller variable. So keep going further negative. So this is just a couple quick examples. All right. Quick modeling problem. A circuit overloads at 1800 watts. You plug in an 1100 watt microwave, and we want to write and solve an inequality that basically represents this situation. So oftentimes in these problems, we're going to look for a number that either reads as a maximum or a minimum. If our circuit overloads at 1800 watts, that's the most we want to plug in. So that's a maximum. I'm going to just write that note there. So 1800 is a maximum. Okay. On the other side of the inequality symbol, so I don't know what I'm going to put here yet. I'm going to write my stuff. I've got an 1100 watt microwave, and I'm going to add some more stuff. I'm going to use X for the rest of the stuff because I don't know exactly what we're going to put in yet. So we've got an 1100 watt microwave, plus I'm going to plug more stuff in. That's the stuff we could add. And 1800 is a maximum. So I can't go over 1800. Am I allowed to be at exactly 1800? Well, the way we decide whether or not to put that line is from the wording of the problem. Does it overload after 1800 watts or at 1800 watts? It says at, which means I don't even want to hit the number 1800. So I am not going to put the line underneath this. This would be the answer I'd expect. That would be the perfect way to write this out. Part B of the problem asks us, what other stuff could we add to our outlets? And so we've got a little table of stuff that has its own watt measurements here. So if our equation is 1100 plus x is less than 1800, maybe a little bit of mental math will tell you what x is, but we can also do a solving step. And I end up with 700 watts left. I can't use another 700. I have to stay less than that. So right away, looking at this table, we should be like, anything bigger than 700's just got to go. But now what about the blender and the clock radio? Well, 300 is less than 700. 50 is less than 700. Can I do both at the same time? Well, that's only 350. So with a nice small table like this, it doesn't get too complicated. The The more options we have, the more we have to write out complicated answers. But we can use a clock radio, the blender, or both. That would be a nice, full, complete answer. So if we found this result, and then we wrote out the things we could use, that would be a beautiful 100% credit solution. So multiplying or dividing adds a little bit of a special rule. So if we're multiplying or dividing a positive number, nothing actually changes. No rule change for that. But if we multiply or divide by a negative number, our algebra steps don't really change. But there's one special thing that we have to do because it's an inequality. Flip, and in class I'm going to have you guys shout that at me, but flip the inequality symbol. And I want to give you a quick reason why that's true. So I'm going to draw out a number line here. And we're going to pretend that I'm at positive 2. So here's a 1, here's a 0, here's a negative 1, and here's a negative 2. Now we're going to pretend that I'm greater than or equal to 2. So just fill that out. Everything on here should be a solution. So 3 should also work, 4 should also work for my inequality. If I multiply by a negative 1, I want the negative version of all of those to be part of my solution. So basically what's happening, and bear with me here, I'm going to try to draw this as a picture so you really have a graphic in mind, is I'm swinging this entire inequality around. This is kind of like my action shot of what's happening. I'm swinging the entire inequality around so that all of the things that were solutions on the positive side are now solutions on the negative side. So by multiplying by that negative 1, now I should have solutions of all the negative numbers that used to be positive, like negative 3 and negative 4. So this is kind of like my action shot. We add some whoosh lines, whoosh. So multiplying by a negative 1 caused that to happen. So multiplying by negative 1 caused the whole thing to shift that way. That's why we have to flip the inequality symbol. Okay, so this would be greater than or equal to 2. This would be less than or equal to negative 2. So not only did I multiply my 2 by a negative number, but all the solutions by a negative number as well. So hopefully that gives you a little picture of why it works, but let's just solve some equations and trust our rules. We'll plug in some answers to make sure we're right. My goal is to try to convince you that this rule makes sense and works. X over 8 is greater than negative 5. The opposite of dividing is multiplying, so I'm going to multiply both of these by an 8. I multiplied by a positive number, so nothing special to do here. 8 cancels. Negative 5 times 8 is negative 40. Draw myself a nice little number line. Again, just 3 numbers. One above, one below. I do not have the or equal to, so I use an open circle. I'm not committing. I don't want to count that negative 40. Alligator is eating my X, so I shade up. Whee! And that's my solution. All right. Now another problem. Let's say 2 less than y over negative 3. So I have to multiply again, but this time I'm multiplying by a negative 3. So not only do I do my regular multiplication step, but I'm going to write, you'll see me do this whenever I do notes or problems at the board too, flip. So these negative 3's cancel out. Negative 3 times 2 is negative 6. But now instead of that symbol, I'm going to flip it and make it the greater than symbol. So this is what flipped the symbol. Now I draw my number line, and this time we're going to check our work. Just I want to convince you that flipping the symbol was the right thing to do. -6 is the number we're compared to. A number above and below, so -7 and -5. Open circle because I'm not or equal to. And now which way do I shade? Alligator is eating the number, not my y. So I'm the smaller stuff because the alligator was eating the thing on the other side. So I should shade further negative. So let's make sure this worked, both in our original problem and in our answer. So y less than -6, that's obviously going to include -7, -8, any number that's a bigger negative number. I want to plug that back into our original and make sure it worked. So when I plug a number in over here, it has to be bigger than 2. Well, what's -7 divided by -3? That's 2.5, positive 2.5. That worked. How about -9? Let's try one that's going to come out to an even number. -9 over -3 is positive 3. Again, that's bigger than 2. So all the numbers going that way on the number line are the correct solutions. So hopefully that convinced you that flipping the symbol was the right thing to do. If I choose numbers on this side, my original expression, my original inequality is not going to be correct. So flipping was necessary. One more modeling problem, then we'll be done for the day. So this problem tells us we're working $9.50 an hour. Whatever job we're working, that's what we're getting paid. So that's going to be a useful piece of information. So our goal is to write and solve an inequality for how many hours we need to work to afford a $247 digital camera. Sorry if it looks like a 9, it's supposed to be a 4. So $9.50 per hour for a certain number of hours. So $9.50 per hour, whenever we see that word per, or we know it's like each amount of time or each time we buy something, so that each idea is usually going to have a variable with it. So hopefully it makes sense to you why I would write 950 times h. H is the number of hours I work, so $9.50 times that number of hours. All right, now 247. Is that a maximum or a minimum to buy the camera? Do I need that much or more, or that much or less? Well, less doesn't make sense, because if I don't have enough money, they're not going to give it to me. Unless I walk in there and yell at them a little bit, but maybe they'll give me a discount. I need to make at least that much. They'll take exactly $247. Now we're pretending tax doesn't exist in this situation, but they'll take the exact amount, but it doesn't hurt for me to walk in with more money. It's not a bad thing for me to have more money. So if you remember me saying that inequalities were technically better for real life than equations, this is why. It's okay for me to work more hours and have stuff left in my pocket after I buy this camera. So all this takes is dividing by 9.5, $9.50. Think to yourself, do I have to follow that special flipping rule? I'm dividing by a positive number, so no, I don't. I'm not going to flip that symbol. So h should be greater than or equal to, gosh, I didn't plan out the answer for this one. All right, you're going to watch me do some longhand math here. All right, how many times does that go into 576? Yeah, 6 exactly. Okay, so 26 hours. If you learned that back in elementary school, hey, if you forget a calculator, it can still help you out. So I have to work at least 26 hours. More than that is fine, but 26 is the minimum I have to work, because $247 is the minimum it takes to buy the camera. All right, thanks guys. Make sure you look at the notes, try to fill out the problems. We'll do a couple more on there that I skipped in class.